So we've indicated that the northwest corner rule is one of them. The next one is a minimum sell cost method. Now, there are problems. There are a few problems with the northwest corner rule that I want to just quickly mention. The solution is a feasible one because the demand and the supply constraints are all satisfied. So there's no question about that, no problem. But it ignores costs of shipping over each route. Okay, what do I mean? Okay, when you look at it is just shipping to the route, whether the cost is higher or the cost is lower, it's just shipping. It's just shipping. It's just shipping there. So if you look at it, it is ignoring those areas where costs are smaller. And so that is one kind of, cons on that. So the total cost cannot be set to be fully at a minimum cost. And so after finding this initial feasible solution, we need to check for the least. And that is why later on we'll improve it using the stepping stone method, which is an iterative method for moving from the initial feasible solution, to the optimal solution. So that is a key point that I want you all to note on that. One interesting thing about the stepping stone, I'll come to that. It checks if a cell with no allocation can still be used to reduce the cost. Okay. But before that, let's go to the next approach of initial feasible solution, the minimum cell cost method. So coming back, we still have our transportation table here. Okay, you can see that all the costs are there, and we have our supply, and then we have our demand, everything as it is. Now, the logic here is to allocate to cells with the lowest cost. So don't just allocate, but give it to the cells that have the lowest cost. Can you type for me, which cell has the lowest cost? We normally will mention 1A or 1B or 2C or 3C. So which cell has the lowest cost there? Okay, which cell do you guys see as having the lowest cost? Type it in there, let me see. Which cell has the lowest cost? A, 3. Okay, so 3A, that's what you mean, 3A. Fantastic, Eunice. So that is 3A, okay? So in our table, 3A has the lowest cost of $4. And the most optimal tons, let's look at it, okay? What is the total number of tons that can be supplied there? What is the total number of tons from this supply of 275? What is the total that can be supplied there or can be demanded? What is the total that can be demanded? There's no question that I can only accept 200. So you send 200 from here to there and give it to that, okay? So that is the thing. So 200 can be demanded since the 275 will be too much. So that's the first thing you want to do. Now that will eliminate all the cells in column A. So because the 200 has been satisfied, so nobody will be handled here. So even if the next one here would have been a smaller cost, you can't send anything there. So you cannot include that, in there. So that's the first thing. So it means that everything at column A is ignored. We now look at column B and see whether the leftover can be given to column B. And so the next allocation is for cells with a minimum feasible cost. Now, if you look at it, so this section, I'm saying that even if the next one here was 5, you cannot send it to that 5 because the column A has been taken. So the next column, the next area, so the entire space, which one has the smallest one? And that is this 5. Okay, it's 5. And remember, we are dealing with the row first. Okay, we are dealing with a row and exhaust everything here. And that is that. So we'll send 75 to the column B, which gives us a cost of $5. Okay, and that will satisfy all of this. So 3B with the cost of that, okay, and most to be sent there is the 75. Now, so we now have 200 sent to this section And then we have the 75 also bundled up to this. What next? Well, you can see that the supply section has been gone to 0, so we have been able to clarify all of that. What would be the third allocation? Who can tell me? Looking at this, what would be the third allocation? What would be the third allocation? Sell what? Which cell? Who can guess? Type it there. What would be the next cell allocation? If you look at it carefully, the next, yes, Ebenezer, type it there. Just type it. Don't need to raise your hand. Just type the answer. Okay, fantastic. Okay, so somebody has indicated the answer, right? The B1. Okay, but we call it 1B. So it is 1B, and 1B has a cost of $8. Now, we've already said that 1A, okay, and 2A were already ruled out as infeasible. Okay, so most of the items will be sent there. Now, 150 will have to be sent there. 150, but then it already has 100. It already has 75. Okay, and so to get the total is demanding, you need to send what? 25 to 1B. So we send 25 to 1B. Okay, then let's quickly do the next allocation so that we'll get it. So you send 25 here, you'll be left at 125. Okay, then 125, you give it all to the 10. That exhausts this supply. Then you are left at 175. Okay, 175, you are going to now give it all to this one. Not that, because this has been succeeded, so you give it all to the 11, and that satisfies everything. Okay, and so eventually we have this as a transportation to this is a 175, and then this is a 125, and we're able to supply ourselves to all this. Now that we've done, so we started with the minimum cost, and then we search, making sure that we are satisfying supply and demand every time. We searched and searched until we got that. So at the end of the day, we are going to have these items multiplied by the respective costs. Okay, we're going to have these items multiplied by the respective costs. These items multiplied by the respective, and then we'll be able to know the overall minimum cost. Okay, the total minimum cost that will be generated right here. And so take them, multiply it by their respective minimum cost, multiply, and then this is what you have finally. You're going to substitute them into the objective function and multiply them, and you're going to get $4,550 for the minimum cell cost method. So what is the difference between this and the northwest corner rule in terms of cost? Well, the total cost here is less than the northwest corner rule because that one was $5,925. So you can see that the northwest corner rule does not consider cost at all, whilst the minimum cell cost approach considers cost. Okay, so that is it. That is how it does in that particular regard. So that is the minimum